right, class, welcome back to our lesson on inscribed angles. We're going to finish this thing off with another inscribed angle theorem, and it's very similar to the previous ones that we had talked about. So let's do a quick refresher from video 1. If you haven't seen that one yet, totally worth it. So the notes we went over in video 1 were about what an inscribed angle is and its relationship to the arc it intercepts. So we know that the angle is half the arc. And that is the takeaway. The angle is half the arc. Okay, so we're seeing the difference between the central angle where stuff was congruent versus the inscribed angle where it's half the arc it intersects. So there's another note that deals with that same relationship. It's not necessarily an inscribed angle. Well, it's not an inscribed angle, but it is formed by a tangent and a chord. Okay, so this particular angle is formed by a tangent and a chord. So if you have a tangent to a circle, and in this diagram it's a little bit hard, it's tangent to a circle, the angle that is formed by that tangent and that chord, the angle here by the tangent and the chord, is going to be half the intersected arc. So here we go again, the intersected arc between the angle and the chord. Okay, so that arc intercepted here is, again, angle is half the arc. So it's the same thing as before. The angle is half the arc. So what if we were looking at the bigger angle? So if we have our tangent line here and the chord that it's meeting with, so we have an angle between the tangent and the chord, and hopefully you see the arc that is intercepted. And so you see the arc that is intercepted right there, and the relationship between the angle and the arc. Once again, the angle half the arc. So we're having that same relationship. The angle is half the arc. So that is so good to know. That's an S. The angle is half the arc. So another relationship with that. So that's it for the note. Now let's see how this plays out in a few examples, and hopefully it'll become a little bit easier to deal with. So here's our first diagram. In this diagram here, we have line SR tangent to the circle at Q. So here is our tangent line. The question is about the measure of angle PQR. So the question is about the angle measure here. Now, hopefully what we're able to see is the arc that it intercepts. Do you see the arc that angle intercepts? Hopefully you do. Hopefully you see the arc is here. Okay, and we know from the note that the angle is half the arc. But we have to look at what is given to us. What is given to us is the arc measure PMQ. So what we're given is what I'm highlighting in red here. So what we're given is the arc PMQ, and that is 212. So how are we going to figure out the angle PQR? Okay, well, we know some stuff about some stuff. And there's a couple ways that we can do this. You don't have to do this just one way. You can maneuver your way there. Because with this arc measure, we actually know now the angle PQS, right? We know this angle, PQS. And if we know angle PQS, we know about linear pairs. We can find PQR. We can do it that way. Or we can say, hey, given the arc measure of 212, we know that the arc for PQ is going to be 360 minus 212. So we take some stuff away, 148. So we already know that our arc measure here is 148. And we know that the angle is half the arc. So the measure of angle PQR is half the arc it intersects. So the angle is half the arc. That leaves us with the measure of PQR at 74 degrees. Okay? Now, does that jive with the other way? Yeah, absolutely. Since if we're looking at the red angle, right, if we had the red angle, so 212 is the arc, that makes the angle PQS is going to be half the arc. It'll be 106. Okay, so our angle inside here is going to be 106, which makes a linear pair with 74. So everything checks out. We can do it a couple different ways. But really, it's about seeing the angles and seeing the arcs. Let's do one more example of this particular note at play, and we'll call it a day, because this one's a little bit fun. So here's our diagram. We see that ray KJ is tangent to the circle at O. Is tangent to circle O, excuse me. So ray KJ is tangent to circle O. So we have a tangent line here. And now the question is, what are the values of x and y? There's so many different ways we can approach this. So the first thing we can do is look at our note. If we're considering angle x, for example, angle x I'll highlight in red. Here's our angle x between the tangent and the chord. Okay, and that is totally our note, right? That's our note, between the tangent and the chord. So that's the note we're dealing with. If we have our angle between the tangent and the chord, here's the arc that it intersects, or the intercepts. So we have to be able to see what's happening. So if we know that arc measure, and clearly we do, then we know the angle. What does that mean? Cats, what do you mean clearly we know the measure of that arc? Yes, yes we do, as a matter of fact, because of the previous video. This arc, not only is it made from angle x, it is also made from the inscribed angle q. Okay, so we can follow our line here. It's the same arc that's made from angle q. And that angle measure is 35. And as we know, the angle 35 is half the arc. Okay, so it's half of basically arc JL. So how do we find the arc JL? Well, we just multiply both sides by 2. We know that the arc JL is going to be 70. So arc JL is 70 degrees. So arc JL is 70 degrees. And if arc JL is 70 degrees, we have our note at play, because once again, the angle is half the arc. So the angle, now we can see our x is half the arc, half of 70. So x is actually 35 degrees. Now, take a moment and think, wait a minute, that's so cool because wait, 35 degrees is here. That's messed up. Well, if our 35 degrees here and x is also 35 degrees, well, isn't that weird? But yeah, check it out. It makes total sense. Both of those inscribed angles intercept the same arc. They should be congruent. Okay, so indeed it does make sense. So we have found our x. Now you might be thinking, well, what about y? What's going on with angle y in here? If we look at y, you might be drawn to seeing, okay, well, I need to find the measure of arc QJ, and I can figure out y, right? You may be thinking that, and that's a total possibility, and we can, because QJ with JL makes a semicircle, makes 180, right? And so if JL is 70, QJ has to be 110. Okay, so if we find that, then we can find angle y. So you can totally do that. Angle y is 55. We can do it that way, there's no doubt. But there's another way of looking at it. Okay, so we already know y is 55. But how can we look at this a different way? Notice what's happening at angle J in the triangle. This angle here is intercepting an arc that is a semicircle. And if it's intercepting an arc that's a semicircle, we know it's a right angle. So we can tell that in the triangle, angle J is a 90-degree angle. And if we already know this angle measure is 35 and this measure is 90, that's how we can find y. Well, once again, 55. So there's different ways that we can do it. We can either say y degrees is going to be half the arc that it intersects at 110, which is 55. Okay, so we could find out y is 55 degrees. Or we could say that, well, 35 plus 90 plus y equals 180, because those are the three interior angles of a triangle. So we have 125 plus y equals 180, and we subtract 125 from both sides, and voila, 55. So either way, y equals 55 degrees. No matter how you slice it, you're going to get the same way. So there's many different ways to skin a circle in this lesson. So hopefully that was helpful with our new note, and hopefully that was helpful with our other notes all about inscribed angles. So now we know, and I'll meet you next time for angle measures and segments. When we get into segments, it gets fun. All right, take care.